So hi guys, hi, good evening. So hi YouTubers, good evening. Waiting for more students to arrive. So it's 5 p.m. and waiting for students to arrive. If yes, hi, good evening, Bhargav. So let us wait for some students to arrive. Once all students have gathered, we can start our class. Okay. So I hope everyone try to revise the previous concepts which we had thought, which we had learned. So in today's class, we'll be learning about yes, yeah. Okay, guys, cool. Thank you, bro. Okay, in today's class, we'll be learning about the capacitance, so the parallel plate capacitor, the most common type of capacitor which we use in our day-to-day life. So we'll be learning about parallel plate capacitor, which are the other different types of parallel plate capacitor which we have used so far, and we'll also learn about the circuits. So we'll learn about the energy stored inside a capacitor. We'll learn about the derivation for that, and also the derivation for parallel plate capacitor, capacitance of parallel plate capacitor. We'll solve some problems based on them, and if time exists or if time permits, we'll also discuss about the electric field energy density. Okay, so we can solve more problems on them. Yes, guys, cool. So hi Karthik, sorry, it's Kriti. Hi Kriti. So waiting for more students to arrive. Like there are a very less number of students right now. Please try to invite or call all your students. I mean, all your classmates to the class so that we can start the class early. Hi Nityashri, good evening. So hello guys, good evening everyone. So so hope everyone is doing great. So waiting for everyone to arrive. So once everyone is here, we can discuss. We can start the class. So meantime, I'll be starting my technical poll check. So I have launched the technical poll check, guys. You could let me know if my voice is clear to you, if it's audible clearly, and if my screen is visible to you guys. Hi Prakash, good evening. So please call all your friends to the class so that we can start the class. Come on, guys, YouTubers, please notify your friends about the class so that we can start our class now. Hello, hi guys, hi, good evening. So everyone, please try to be on time, guys. So from yep, that way we can cover most of the syllabus. So guys, please give the technical check. So I have launched the technical poll for you guys. If my voice is audible to you guys and if my screen is visible to you guys. So please let me know if my voice is audible and the screen is visible. Thank you. So someone is having facing some difficulty in watching the screen. Please check your network connection and also your please sit in a place where you get a proper network so that we don't get any disturbance while listening to the class. Okay, cool guys. Okay, thank you, bro. Okay, cool, guys. So let's check that. Okay, let's start the class with the revision. So in what did we start with in yesterday's class? So in yesterday's class, hi Hari Prasad, hi Bhargav. So good evening, guys. Yep. So in yesterday's class, we had started with the capacitance, basics of capacitance. So yes, I'm going to end the poll, guys. Thank you. for notifying me. So yes, what did we start with in previous class? So in previous class we studied about capacitance. We started about capacitance. What is capacitance, guys? So the basic definition of capacitance. So we started with the basic definition of capacitance. What is capacitance means? Say it is the amount, it is the capacity of a body, right? It is the capacity of a body to store what? To store electrical charges, right? To store charges. For what? For what condition? For given potential, right? So this is what we studied in our previous class. So this is called as capacitance. Capacitance is nothing but the capacity of a body to store charges for given potential. What is the what is the expression for capacitance given, guys? Come on, reply. It is C is equals to, yes, correct, Hari Prasad. So C is equals to Q by V. Correct, Prakash. Correct, Raj Lakshmi. Right. So C is equals to Q by V is the expression used to, I mean, is the expression which denotes the capacitance of any body. Okay. Now again, then what is the SI unit of capacitance? SI unit. SI unit. Hope everyone remembers. Yes, it is farads. Farads is the SI unit named after Michael Faraday. So after this, we studied about the capacitance of a spherical conductor. Right. So, can a conductor have capacitance, guys? The next question, like in yesterday's class, we discussed, right? So, can a conductor have capacitance? Yes, right. So, yesterday we discussed the capacitance of a spherical conductor. Okay. So, what was the capacitance of a spherical conductor? Please reply in the chat box. Everyone, guys, YouTubers. Yes, correct, Ramakrishna Reddy. Correct, Bhargav. Correct, Hari Prasad. Yes. So, what is the expression for capacitance of spherical conductor? Prakash, Raj Lakshmi. Someone reply. Try to reply, guys. What is the capacitance we got? So, in yesterday's class, we had derived an expression, right? So, what we considered, we had considered a spherical conductor. So, for of radius r. Now, to this spherical conductor, if I give some charge q, say with some, it's filled with charge q, then it has an potential v. Then the potential v was given by some expression from electrostatics which we learned. So what was the expression for the capacitance of this spherical conductor? C equals to, so it had a capacitance C, right? What was the expression for capacitance of spherical conductor? Yes, correct, Bhargav. So it was, yes, correct, Ramakrishna Reddy. Cool, superb. So it was 4 pi epsilon naught times of r. So from this expression, what did we conclude yesterday? From this expression, what did we conclude? From this expression, we concluded that the capacitance depends only on what? Only on what? Come on, guys, please try to reply, respond. Geometrical properties. Depends only on geometrical properties of body. Yes, of medium or conductor or body. So I'll say it's body, conducting body. Say here it depends only on the radius of the conductor. Here the capacitance depends only on the radius of this conductor. Okay. Next, we also checked for how to increase the capacitance. How to increase the capacitance? So how did we increase the capacitance? Please try to respond so that I will get an idea that you guys have understood or have revised yesterday's class, so that I don't have to repeat everything again. So how did we increase the capacitance of capacitor? Say how can we increase the capacitance? Say when we have a conducting body, so when we had conducting bodies, how did we increase the capacitance? Yes, We can increase the capacitor by either increasing the Q or what is the other thing. So we can increase the capacitance C is equals to Q by B, right? So we can increase C by either increasing the Q or one more Chinmay. Yes, correct, Ramakrishna Reddy. Cool, superb. So my potential decreases. Yes, correct, Rakesh. Correct, Chinmay. Either by decreasing the potential or by increasing the amount of charge, we can increase the capacitance. Say I don't have the possibility of increasing the charge, but I can decrease the potential. Say how can I decrease the potential? Say if I had two conductors in yesterday's class, we studied this. Had two conductors A and B. One conductor is charged with positive charges, and other conductor is charged with negative charge, opposite charge. Then the net potential between these two reduced as, if VA and VB are the potentials, then the net potential was net potential. What is net potential, guys, in this case? VA is nothing but VA minus VB, right? So my expression changed as Q by VA minus VB. So my net potential decreased. So the capacitance increased, right? So we studied this in our previous class, and also we studied about yeah. So if we reduce the potential, the capacitance increases. Okay, I think we stopped somewhere here, right? Did we continue further? I think we stopped somewhere here. Then we thought, I mean, then we discussed about the Leyden jars, if I'm not wrong. Please let me know. Yes, this is the point where we stopped. Yes. So I hope everyone tried to check what are Leyden jars yesterday. How many checked this, guys? Try ಮಾಡಿದ್ರಾ ನೋಡೋದಕ್ಕೆ? I mean, did you guys try? Did you guys check what is a Leyden jar? How was it used? And I also asked you guys to check what a taser is, if I'm not wrong. I hope you guys checked it. Okay, cool. So in today's class, we'll be starting with the parallel plate capacitor. Okay, so in general, whatever the capacitor you have seen in any circuit boards or motherboards or any TV remote, whatever the boards you have seen, or whatever the type of capacitors you have seen, most of them are parallel plate capacitors only. So we'll learn about them in detail. Okay, so in today's class, we'll start with that. The most common type of capacitor which we see in the any most common type of, yes, the most common type of capacitors we see in any circuit would be a parallel plate capacitor. Now, how can a parallel plate capacitor be constructed? So let's study the construction. Okay. So for construction, let us consider, okay, two plates. Let us consider two electric plates. Okay. So I have two electric plates. So I'll call one plate A and the other plate B. So yes, these two plates are having the same cross-sectional area. So construction of this parallel plate capacitor has, say it has two parallel plates, two plates of same area of cross-section. Now these two plates are separated by a distance d. Okay, these two plates are separated by a distance d. So if one of the plates, say I call the first plate as the first plate is on the left side, is charged with Q, positive charge Q, and the other plate is charged with a minus Q charge, a negative charge Q. Now what happens, guys? Tell me what happens in this case when I charge one of the plate with positive electrode, I mean positive charges, and if I charge the second plate with the negative charges, what happens here? What would happen here in this case? Guys, tell me. Say, okay, tell me this. If I have a positive charge here and a negative charge here, what happens here in this case? Yes, correct, Dhanush. Say in this case, there exists a field, right? If you remember, there exists a electric field. Similarly, even in this case also, there exists an uniform electric field of magnitude E. There exists an uniform electric field of magnitude E. Okay. This electric field is originating from positive plate Q, I mean positively charged plate of with magnitude plus Q, and ends at negatively charged plate minus Q. Okay, so this is a construction of a parallel plate capacitor. So now the each plate, see, since these plates are completely charged with or uniformly charged with this charge Q plus Q, then the surface charge density on both the plates is given by sigma is equals to Q by A. Okay. Okay, guys. Yes, we'll come to that, Hari Prasad and Ramakrishna Reddy. We'll come to that condition in the upcoming concept. Okay. So now my electrodes, there exists an electric field between these two plates. So what can I say? Say these two electric plates hold some charges, and there exists an electric field between these charges, and there also exists a potential. Okay, there also exists a potential between them. Say because of the potential only there exists some charge. Okay, now now this construction, the same construction, if I want to represent it in 2D, so this is the 3D structure. This is the 3D structure. I'm trying to represent everything in 2D. Okay, so neglecting the edge effects. So here we show this electric field lines are only in this direction. See, only in the midpoint we have shown in the middle bit between the plates of the conductors only, or between these plates of capacitor only, we show the electric fields are in a straight line. Now, yes, Hari Prasad, we can calculate. We'll discuss that. Okay. We'll discuss that later. So we have that these electric field lines, but actually in actual we are neglecting the edge effects. So what is edge effect? Someone, can you say? Can you say what is my edge effect? Guys, is there any trouble with my screen? Vinay? I know. I don't know. My screen got shut down. Why? Guys, there is some technical error. Please wait so that I can launch the screen again. No, why did this happen? So, guys, just a moment. Yes. Okay, guys. So I guess my screen is visible now. Yes. So cool, cool. Thank you, guys. Thanks for the confirmation. Why? Okay. I don't know why. What's happening here? Okay, cool. Okay, guys. So hope my screen is visible completely now, but I don't know. I'm not able to check the chats. Yes, now it's visible. Okay, cool. So I don't know why there was some glitch. Sorry for the glitch. Okay, guys, come on. So I was discussing about the neglecting of edge effects. So what do you mean by edge effects, guys? So we had started with the construction of a parallel plate capacitor. Say here, yeah, we have two plates, two parallel plates of same area of cross section, separated by a distance of small d, and one of the plates is charged with plus q charge uniformly, and other plate is charged with minus q charge uniformly. Now there exists an electric field, uniform electric field between these two plates. So this is the 3D structure and this is the two-dimensional structure. I'm trying to represent them. Okay, so this plate is in front, this plate is in back. So yes, now yeah, what do you mean by edge effects? Come on, guys, reply, please. Please try to reply. What do you mean by edge effect? Okay, Bhargav says Edge effect means at edges, electric fields will deviate outwards. Okay. So, guys, whatever the electric field which I have shown here, the electric fields which I have shown here are only between the plates of the capacitor. But what happens sometimes the electric field, usually in practice, what happens, there will be the electric field lines are always curved lines. Okay, are always curved lines. Whenever we have tried to draw electric field lines for any 2 point charges, we have already always tried to draw the curved lines outside, except in the middle, right? In the middle, we have tried to draw the straight lines, but in any other place, in any other places, we have tried to show only the curved lines. So this rule of drawing electric fields we had discussed in our electrostatics chapter. So here what happens is, outside this, just outside the surface of this plates, what happens, we have, there will be existence of curved lines, curved electric fields like this, only in between the plates of the electric fields. Sorry, only in between the plates of this capacitor, the electric fields will be uniform straight lines. Okay, got this, guys? Please click on yes if you have got this. Artha ಆಗಿದ್ಯಾ? Please click on yes if you have got this. This is one condition. So edge effects, in edge effects, say there was a question for you guys in NEET. Actually, there was a question for you guys in NEET. I've added that question in your concept test. So what happens, say they have asked which is the correct which is the correct representation of electric field lines between the plates of a parallel plate capacitor. So they had asked a question based on this. So are you clear now? So then in the edge effect, what happens is, at the edges, my electric field lines form curvish lines. Okay, my electric field lines are curvish at the edges. So I have neglected those edge effects here. Now let us try to derive the expression for the capacitance of parallel plate capacitor. So let's consider. So we know that the capacitance of any capacitor is given as C is equals to Q by V, right? Then, so we know that, again, we know the electric field lines. Say in this case, where is my electric field lines originating and ending? Guys, reply. So in this representation of parallel plate capacitor, where is my electric field lines originating and ending? I'll show edge effects. I tried to show now. Say in your edge effects is not. It's usually neglected. So that's very uh, less, Lakshmi. Yeah. So the point charges which I showed, that can be an example. Say we can see that we can show the electric field lines are curvish in the outside, but in middle we show it's a straight line. Yep. So guys, yeah. So coming back, I was talking about this. So yeah, please tell me now, where is my electric field line starting and ending, guys? Come on, tell me, please. Yes, it's starting only on the inner surface. Please note that my electric field line is starting only on the inner surface of the plates. Say we know that a plane has two sides, right? First side and the other end is second side. Okay, so this plane, this, if I call this as first side, and the other end where the electric field is originating as second side, so, or this is first side, this is second side, and for this is first side, this is second side. So my electric field is originating on the second side of plus q charge plate and ending on the first side of first minus q charge plate. Can I say this? Or what I meant to say is, my electric field lines originate only on the inner surface of the capacitor, only on the inner surface of this parallel plate capacitor. Okay, guys, my electric field exists only between the parallel plates of the capacitor, only in the inner surface of the parallel plate capacitor. Please note this point. Electric field exists only in inner walls, inner surface, or inner surface of plates. Okay, the electric fields exist only in the inner surface of the plates. So what do you say the electric field on only positive charge? I mean only on the positive charge plate. How much is the electric field on the only? So electric field lines, why are they not in the outside? So guys, in general, what happens? These are connected with LEDs, right? So if I connect this to something else, say in general, what happens? The parallel plate capacitor. If I connect these to outer LEDs, so I'll show you how these are represented, how these are in actual. Say if for electrical connection, what I have to do, I have to solder two wires to the other two plates, and I have to connect this to some battery or something like that, right? Have to connect this to some load or battery or something like that, right? So at this condition, what happens? There won't be, so these charges which are on the other end of the plates will not be present there. So it will be either taken away or either given. So we'll study about that in detail later. But for now, let's assume that the electric field lines only exist on the inner surface of the plates. Then, can you say what is the electric field on one of the plates? What is the magnitude of electric field on one of the plates? Guys, what is the electric magnitude of electric field on one of the plates? We had studied this now. Tell me. E is equals to. So on one of the plates, the electric field is given by E is equal to sigma by 2 epsilon naught, right? So we'll be using this condition. We'll be using this. The surface charge density of on the plates of the capacitor is given by sigma is equals to Q by A. We'll be using this from the previous chapter. Okay, in this example. So it's given by E is equal to sigma by 2 epsilon naught. Correct, Hari Prasad? Thank you. So the capacitance of this capacitor is given by, say in general, we can write C is equals to Q by V. Now, in order to find V, I need my electric field E. So what happens? What is the value of electric field on one of the plates? So the electric field on one of the plates is given as E is equals to sigma by 2 epsilon naught. You know this now, guys. Please respond. ನೀವು ರೆಸ್ಪಾಂಡ್ ಮಾಡದೇ ಇದ್ರೆ ನಾನು ಹಿಂಗೆ ಮುಂದೆ ಹೋಗೋದು. Okay, next. So for two plates, the electric field between the two plates is then given by E is equal to sigma by 2 epsilon naught plus sigma by 2 epsilon naught. Right? Yes. Yes. Cool. Thank you. Then what can we say about the, yes, then what can we say about the net electric field? What happens? Uday, there is how to respond. Uday, in participants, in there you can see at the right bottom screen there is something called as participants. So if you click on that, there you will get yes, no, go slow, go faster, more. So these buttons are the non-vocabulary response. You could click on yes if you have understood, click on no if you have not understood. Okay, so everyone who are new to this class, please follow that. Thank you. So cool. Thank you. Next, okay, we'll come to this. So the electric field for two plates, between the two plates is given by E is equal to sigma by 2 epsilon naught plus sigma by 2 epsilon naught. So on summation we get, now to calculate the electric potential. So what is the net electric field we get? The net electric field we get is sigma by epsilon naught, right? So my final electric field between the two plates is given as the summation of the electric field between the individual plates. That is given as sigma by epsilon naught. Now, can we calculate the electric potential using electric field? Guys, can we calculate the electric potential using the electric field expression? Yes, we have to find this. We know that V is equals to E dot R, right? V is equals to E dot R, where R is the suppression. But here we have the suppression between the plates. Say we had two plates. One is charged with plus Q and other is charged with minus Q. And the separation between these two plates were B. So there exists an electric field E between these two plates. Okay. So these two plates are separated by a distance of B. So I'll write my electric potential V as E dot D. So you know that V is equals to minus E dot D. Now considering only the magnitude. So we want only the magnitude of V to calculate. So I'm neglecting the negative sign. So on writing this, we get C is equals to Q by E dot D. So any doubts still here, guys? Please let me know if you have any doubts. Please click on yes if you have any doubts. Click on no if you don't have any doubts. Okay, no doubts. Cool. Thank you, guys. So next we'll go on solving. So now we know that, yes, we know that V is equals to E dot D. Then we got C is equals to Q by E dot D. Next, what can I write my Q as in terms of surface charge density? So from surface charge density, we know that sigma is equals to Q by A. From surface charge density, the surface charge density is sigma is equals to Q by A. Then what is Q? Q is nothing but sigma times of A. So substituting this in the previous equation. So substituting this Q value in this equation, what do we get? We get all the values we get. C is equals to sigma A by E times of D. Now also substitute the value of E. What is my E? What is my E? E is sigma by epsilon, right? Also substituting the value of sigma in this equation, we will get this. We'll get this expression as sigma A by sigma by epsilon naught into D. So guys, what happens now? Again, I'll calculate and cancel my epsilon sigma value from numerator and denominator. Then what is left to me? So what is left with me? So we'll rearrange this. So we'll get C is equals to epsilon naught A by D. So this is the expression for the capacitance of a parallel plate capacitor. Okay. So we have we have got this expression. So what can we conclude from this expression? Guys, any doubts in this? I hope everyone have got this derivation. Please click on yes if you have got the derivation. Click on no if you did not get. Yes. Cool. Thank you, guys. Thanks for noting. So this is expression for the capacitance of a parallel plate capacitor. So therefore, from this expression for the parallel plate capacitor, that is C is equals to yeah, C is equals to epsilon naught A by D. From this expression, what can we conclude? So we can conclude 2 points. We can conclude that the capacitance depends only on the geometrical properties. Again, this is very, very important, guys. So this we have tried to prove this in all conditions. My capacitance only depends on the geometrical properties of the conductor. So what are the factors where my capacitor is depending on in the parallel plate capacitor? It's depending on the area of the capacitor and it's depending on the surface. I mean, it's depending on the distance separated between the plates of the capacitor. Okay. Next, now the capacitance of parallel plate capacitor. How can we increase its capacitance? So using this expression, can you guys tell me how can we? Yes. How can we increase the capacitance of the parallel plate capacitor? Yes, correct, Bhargav. So C is directly proportional to A, inversely proportional to D. So C is equals to epsilon naught A by D. From this, using this equation, yes, correct, Rajalakshmi. So we can increase the capacitance of this parallel plate capacitor by first thing, we can increase it by increasing the area of cross section of each plate. Say if we increase the area, say we know that C is equals to y. C is equals to epsilon naught A by D. So if I increase the area, my capacitance increases. Again, using the expression C is equals to epsilon naught A by D. If I decrease the distance between the two plates, my capacitance increases. Okay. Or so we have one more thing. Apart these two, we have one more thing So to increase the capacitance of the capacitor, we can introduce a dielectric. Dielectric means what do you mean by dielectric, guys? Yesterday I told you. What do you mean by dielectric? Hari Prasad, no, it's not increasingly, it's decreasingly. Okay. Yes, correct, Bhargav. So, what do you mean by dielectrics, guys? Come on, reply. Dielectrics andrenu. Really? What do you mean by dielectric? What is a dielectric? So, dielectrics in general, guys, I'm telling again, it's an insulator. Any insulator. Insulators are those which does not conduct electricity. Okay. So, dielectrics means those are just insulators. Okay. So we'll discuss about them separately. So we can increase the value of capacitance by introducing a dielectrics. Then this same expression will change as K times of epsilon naught A by D. So where K is nothing but the dielectric constant. Okay. Where K is dielectric constant. Okay. So this will study separately in a separate unit called dielectrics in the same chapter. Okay. Yes, correct, Bhargav. So I hope I'm clear with the parallel plate capacitor. Guys, any doubts in this? Any doubts in this? Please click on yes if you have any doubts. If you don't have any doubts, click on no. Okay, cool. Thank you. So let me give you a problem to solve. So guys, I have given you a problem. So I have displayed a problem. Please try to solve only for option A. So please neglect this second question. So second question will solve again. So the first question, I'm launching a poll. So everyone who are new to the class, please check that. You'll get a pop out, a poll. So you could answer your option based on these options given A, B, C, D. You could answer your choice in these. Okay. So the question is, there are two parallel conducting plates whose area is given as 20 by 30 centimeters, 20 centimeter by 30, sorry, 20 centimeter by 3 centimeter are separated by 1 millimeter air gap. What is the charge on each plate if my potential difference is 12 volts? Or if I connect a battery of 12 volts, what is the charge stored in this capacitor? Okay, guys, come on, try to solve this. So we'll take only 1 minute to solve this, okay? Not more than 1 minute. Come on, guys, solve this. And YouTubers, please answer the question answer in your chat box, okay? Please try to answer in your chat box. Whoever answered right now, please check your answer again. Come on, guys, try to solve this. So this is just substitution, guys. This is level 1 type question. We'll try to slowly increase the difficulty of the questions. So if I get the what do you say, confidence that you guys are able to solve these, then I can move on to the higher level questions. Okay. Come on, try to solve them. Manohar, no, check your answer. So only 1 out of 3 students who have answered is correct. So guys, I want everyone to answer. Come on. Try to answer, please. So what's the formula we are going to use here, guys? Tell me the formula. So what is the parallel capacitance of parallel plate capacitor? It's given as C is equals to epsilon naught A by D. If someone requires any help in calculation, let me know in the chat box. Manohar, check your answer. So epsilon naught value is 8.854 into 10 power minus 12. Okay. Coulomb square per Newton meter square. So C is 8.854 into 10 power minus 12 Coulomb square per Newton meter square. So everyone please try to answer. So guys, I'm going to end the poll. Please try to respond. Guys, there are many students here and no one have given the right answer. I mean, only 3 students have given right answer so far. Bhargav, please check your answer again. Bhargav, check. Yes, your magnitude is correct, but check with the powers. Okay. Bhargav, check with the powers. Come on, guys. Come on, solve this. Okay, everyone, try to help me and try to solve with me, along with me, if you have not started or if you are solving now. So, what is the value of epsilon naught? We know 8.854 into 10 power minus 12 into what is area given as 20.0 into 3.00 centimeter square, right? Centimeter into centimeter will give you centimeter square, that is 10 power minus 2 into 10 power minus 2. Yes, Lakshmi, correct. Hariprasad, correct. Bhargav, correct. Ramakrishna Reddy, correct. Others, guys, please try to answer. Okay, so why did I write 10 power minus 4? So it's centimeter into centimeter is 10 power minus 2. Again, 10 power minus 2 into 10 power minus 2 is 10 power minus 4 divided by 1 into 10 power minus 3. So if you try to simplify this, yes, you'll get 8.854 into 2. 8.854 into 2. That is, sorry. So I'll try to simplify this. 8.854 into, I'll write all the magnitudes. It's 20 into 30 is 60 into 10 power minus 12 into 10 power minus 4 into 10 power plus 3. Guys, come on. Just simplify this, you'll get the answer. So guys, first question is about the charge stored in the capacitor. Okay, we have to find the C first. So C is somewhere around 53.1 into 10 power minus 6, right? So 10 power 53.1 microfarad. So you got only the value of C here. Now, no Aishwarya, no Prakash, Prajwal, correct? Prakash, check your answer again. So we got only the value of capacitance here. But what do we want? We want the value of Q. What is value of Q? So from the expression Q, C is equals to Q by V, what can we say about Q? Q will be equals to C into V. So multiply 53.1 into 10 power minus 6 into so please check with the powers again, guys. 8.854, sorry, you'll get 531.24 or 50.24 into 10 power minus 12. So that will be 10 power minus 13. If you try to solve this, it will be nothing but 53.124 into 10 power minus 12 farad, that is picofarad. Okay, so this is the capacitance. Please try to multiply with potential. So we know Q is equals to 53.1 picofarads. C is equals to Q is equals to C into V. So Q is equals to 53.1 into 10 power minus 12 into 12. So this will be 637.2. So Q will be equals to 637 into 10 power minus 12. Okay. So if I try to simplify, so I have asked in terms of picofarad, right? So 10 power minus 12. So which, okay, cool, guys. So I hope then the answer should be 637 picofarads in this case. So option C would be correct. So if you try to simplify, you would get that answer. Okay. So guys, yes, hope everyone have understood this. So 637 picofarads would be the right answer. If I'm giving in picofarads, please check Hari Prasad. 10 power minus 2 into 10 power minus 2 is 10 power minus 4, not 10 power minus 3. Hari Prasad. Hari Prasad, it's 10 power minus 2 into 10 power minus 2. That is 10 power minus 4. So I have taken 60 into 10 power minus 4. So I hope you might have taken 6 into 10 power minus 3. So both are same. Okay. So any doubts in this, guys? Yes, I have converted all into same units. So I have converted centimeters in terms of meters. So it's everything is in meters only now. Okay. Bhargav. So 1 millimeter is 1 into 10 power minus 3, and 20 centimeter is 20 into 10 power minus 2 meters. So 10 power minus 2 into 10 power minus 2 is 10 power minus 4. I have written here. So Bhargav. So all are in SI units only. Okay. So any doubts in this, guys? Guys, any doubts in this? Please let me know. Please let me know if you have any doubts. Hari Prasad, no, centimeters, centi means 10 power minus 2. Yes. So 2 into 10 power. So I'll keep it as centimeters only. 20 into 30, 20 into 3, sorry. 20 into 3 is 60 centimeters square. Okay, cool, Hari Prasad. Okay, cool. Yes, 1 picofarad is 10 power minus 12 farads. Okay, how any doubts in this, guys? Any doubts in this? Please let me know if you have any doubts. Click on S. Any doubts in this? Please click on S. Uday, yes. Uday, nodi keli. So 20 into 3. So 20 centimeter. So what's given here? 20 centimeter into 3 centimeter. So ನನ್ನ ಏರಿಯಾದು size ಯಾವಾಗಲೂ ಏನು 20 into 3, that is 60. Centimeter into centimeter is centimeter square. So if I write centimeter, then I'll get centimeter as 10 power minus 2. So centimeter square under 10 power minus 2 whole square. This will be 10 power minus 4. Okay. So everyone, any doubts in this? Uday, artha agidya? Please click on S. I mean, please reply in your chat box. I need confirmation from you if you have understood. So guys, let's move on to the second question then. Artha agidya idu? Don't let's move on, guys. Please click on S, or please click on, okay, please click on S if you have understood, because yeah, I can't move until you guys have given me the confirmation. Thank you, guys. So So let's move to the next question. So first question ತೆಗೀರಿ ಈಗ. So first question ಅಲ್ಲಿ ನಿಮಗೆ ಒಂದು ವ್ಯಾಲ್ಯೂ ಬಂದಿತ್ತು. Now in the second question they are asking you to find what is the electric field between them. So what is the electric field between the two parallel plates? So again area is given as 20 centimeters by 3 centimeters. Separation distance is 1 millimeter. So we had calculated the capacitance in previous case, that was 53.1 into 10 power minus 12 farads. Odam. So what is the electric field between them? E is equals to what? So can we find electric field between them now? Electric field between them. So what was the electric field we calculated in the previous case? So electric field between the parallel plates ಹೆಂಗ್ ಕಂಡುಹಿಡಿಯಬಹುದು? E is equal to sigma by epsilon naught, right? Guys, if you remember, E is sigma by epsilon naught, then sigma is nothing but Q by A. So you have to use all of these, substitute in one another. So you'll get E is nothing but sigma by A times of epsilon naught. ಹೌದಾ? So ಇಷ್ಟು substitute ಮಾಡಿ, can you find sorry, Q by A into epsilon naught. So this is the value of electric field E. ಅರ್ಥ ಆಗಿದ್ಯಾ? Yes, correct, Hari Prasad. Superb. So please try to find electric field for this. So can you find Q if you know C for the same 12 volts? Say if the same 12 volts is given, can you find E? Or yeah, C. You have to find the Q. So you had found the Q in your previous question, right? In previous question we had found the Q, or we had found what? Yen find ಮಾಡಿದ್ವಿ ಇಲ್ಲಿ? Yes, Q ನೇ ಅಲ್ವಾ? Yes, in previous question we had found the Q. Please use the same Q value to find E. Yes. Guys, check your answer, please. Everyone, you could okay, I'll launch the poll for you guys. Please try to answer. Guys, ನೋಡಿ ಅರ್ಥ ಆಗಲಿಲ್ಲ ಅಂದ್ರೆ ಕೇಳಿ. If you are not understanding, please let me know. So yes, okay, please try to answer in the polls, guys. Come on, try to answer in the poll. Okay, Hari Prasad, correct. Bhargav, check your answer. Ramakrishna Reddy, check your answer. Lakshmi, check your answer. Or guys, yep. Okay, let's see the answer. Okay, so num Q ಎಷ್ಟು ಬಂದಿತ್ತು? What was the value of Q we got? Oh my god, I don't have free space. I have to create free space. Guys, my chat box is not visible, maybe because of poor network. I don't know if anyone is answering me, so I can only check my polls. So guys, in previous case we got Q is nothing but 637 into 10 power minus 12 coulombs, right? So we had got 637 into 10 power minus 12 coulombs. So the electric field E is equals to Q by A times of epsilon naught, right? So this is nothing but 637 into 10 power minus 12 divided by what is my A? Again 60 into 10 power minus 4 into 8.854 into 10 power minus 12. So guys, I have 10 power minus 12 in numerator and also in denominator. Can I cancel this? Cancel ಮಾಡಬಹುದಾ? So I'll try to simplify my equations, okay? So can I cancel this and this? See, both are having same signs. Okay. Then 60 into 8.854 is nothing but 53.1. Again, 637. Okay. Yes, correct, Prajwal. Prakash Koda, check. Yes. Come on, guys. Please try to be quick. Please try to be quick. 637 divided by 16 to 8.854 is you will get 531.24 into 10 power minus 4. So if you try to solve this, you'll get 637 divided by 531.24 is nothing but 1.12, sorry, 1.19. So in electric field is equals to, yeah, what we get here, we'll get 1.2 into, yes, what would I get? 10 power plus 4. So if I try to simplify this, what would I get, guys? 10 power plus 4, huh? Will I get 10 power plus 4? Please check that. Yes. So this is not milli, this should be kilo. Guys, please note one change. The option A is 12 kilovolts, option B is 1.2 kilovolts, option C is 2.1 kilovolts, and option D is 21 kilovolts. Okay, so some change in the options. Please, guys, now everyone try to give the answers fresh, okay, in your MCQ. So please try to answer in your polls. So what is my electric field? So sorry for this, some technical error. So this is not, please don't consider these options. Please consider these options. Option A is 12 kilovolts, option B is 1.2 kilovolts, option C is 2.1 kilovolts, and option D is 21 kilovolts. So what's the answer? Guys, everyone, please try to check your answer again. So answer is, Yado. Answer is option A. Okay, guys, 12 kilovolts. So if I try to simplify this is nothing but 12 into 10 power 3 kilovolts per meter, right? Volts per coulomb, sorry. Volts per coulomb. So option A is the right answer, guys. Hari Prasad got yes, correct answer. Ramakrishna Reddy, correct answer. Bhargav, check that. So hope, guys, if anyone have not followed, I will explain again. Okay, please check that. We know electric field E is equals to sigma by epsilon naught. So my sigma is nothing but q by epsilon naught. Sigma is q by epsilon, q by a, sorry. Sigma is q by a. Putting this, I'll get E is equals to q by a times of epsilon naught. Now, my q value from previous equation we got 637 into 10 power minus 12. Okay, coulombs. Divided by my area is 16 to 10 power minus 4 into 8.854 into 10 power minus 12. So I substitute the value of epsilon naught. Illi 10 power minus 12 and 10 power minus 12. Since I have both same values, it will get cancelled. So I get 637 divided by 531.24. If I multiply this, I'll get this into 10 power minus 4. So 637 divided by 531.24 is nothing but 1.2. Okay, it's nothing but 1.2. So this value is 1.2 into 10 power plus 4. So if you try to simplify, that is 12 into 10 power 3. So my first option A would be the right answer. Guys, please click on yes if you have understood. Please click on yes if you have understood. If anyone have not understood, please click on no. Okay, got it. Everyone? Okay, cool. Hariprasad. Okay, guys, next question for you guys. If you have understood that. Yes, cool. Thank you, guys. So next question, guys. Come on, try to solve this similar question. A parallel plate capacitor has plates of area 2 into 10 power 2 centimeter square. Guys, note that the area is already given. Hope everyone is able to see the question. Hope everyone is able to see the question. If someone is not able to see the question, you can try to zoom. Okay, you can try to zoom your screen so that you will get the question. Okay, yeah. So everyone in Zoom can try to zoom if you are not able to see the question. Okay, so the question goes like this: a parallel plate capacitor has plates of area 2 into 10 power 2 centimeter square, and separation between the plates is 1 millimeter. So again, a similar type of question. First question says, what potential difference will develop a charge of 1 nanocoulomb? What is nano, guys? How much is nano? How much is 1 nanocoulomb? How much is 1 nano, or what is nano? Nano, not your Tata Nano. Yeah, unfortunately, Tata Nano is not there. Could solve. Uh, yes, Surendra. Yes, you could. You can solve. E is equals to V by R. Yes, we can apply that also. Yes, nano is 10 power minus 9. So guys, come on, try to solve this first question. I'm launching the poll for everyone. So I'm going to launch the fresh poll for everyone. Please try to solve this. So guys, try to solve for the first question only. Okay, I have given the option for only first question. Don't forget the second question for now. So we'll solve that second question again. Okay. So what is the potential difference? So what potential difference will be developed if a charge of 1 nanocoulomb is given to the capacitor? Say I have a capacitor. So for this capacitor, I'm giving some charge Q. So the value of Q is 1 nanocoulomb. So if I give 1 nanocoulomb to this parallel plates, what is the amount of potential it develops? What is the amount of potential it develops? See, the area is given as 2 into 10 power 2 centimeter square. Okay. Come on, guys, solve this. Okay. So I've started receiving the answer. Cool. Super, guys. So I have received two answers so far, and one is correct, and other one, please check. Okay, two key answers. Two are correct and one wrong. Tejas, yes, correct. Tejas, correct answer. You can proceed to check the second question, Tejas. Tejas, first answer is correct. So you could try to start with second answer. So you can check the magnitude or check the value of the answer. In the second, in the next slide, I have the second question's options. You could answer there fast. Okay, others, please try to answer here. Guys, yeah, 1 point. Hi, Manohar. Hope you guys are solving the problems. Guys, try to solve the problems. Okay, people in YouTube, please try to answer. Come on, guys, try to answer. So let me know if you require any help in calculations. Calculation ಮಾಡ್ತಾ ಏನಾದ್ರು help ಬೇಕಾದ್ರೆ ಕೇಳಿ. So what is the formula we are going to use here, guys? Guys, only 5 students have responded in Zoom so far out of 27 plus students. Please request everyone to answer. Solve ಮಾಡಿ ಹೇಳಿ. ನೋಡಿ ಇವಾಗ just ಕಲ್ತಿದ್ದು, we have just studied this. Yes, guys, come on, try to answer. Cool, super. Thank you, guys. Awesome. So YouTubers, please try to answer. Is it tough, guys? Do you feel it's these questions are tough somewhere? Are you feeling these questions are tough? No, right? Yes, no. Tell me something. Are you feeling these questions are tough? Okay, no, right? Cool. Come on. No, Ramakrishna Reddy, please check your answer again. Yes, correct, Lakshmi. We are going to use that. Yeah, exactly, Lakshmi. We are going to use that equation. So we know that C is equals to Q by V. So we have to find what is V. So rearranging, we get V is equals to Q by C. So Q is already given. So we have to check with C. What is my C? We know C is equals to epsilon naught A by D. Right. Try to substitute this and find C. Yes, Lakshmi, correct. Lakshmi Likita, correct answer. Others, guys, come on. Zoom people. Anusha, Prajwal, correct. Anusha, no ಯಾಕೆ ಹೇಳಿದ್ರಿ ಗೊತ್ತಾಗಿಲ್ಲ. Okay, guys, come on. Try to answer. Yes, guys, come on. So I'm going to end the poll, guys. I'm going to end the poll here. So yes, most of you have given me the right answer here, guys. In Zoom, most of you have given me the right answer. Again, in YouTube also, Lakshmi correct, Bhargav correct, Ramakrishna Reddy, check your answer. Who else? Others, please try to answer, guys. Come on. Okay, so this is the right answer. Option B. So option B is your correct answer, guys. Come on. Let's check how it is correct. So we'll check the value of C first. C is equals to epsilon naught A by D. That is 8.854 into 10 power minus 12 into A. What is my A? Area is 2 into 10 power 2. What is 2 into 10 power 2? What is 10 power 2, guys? 10 power 2 on rest 2. It's 100, right? 2 into 100 is 200 into centimeter square. What is centimeter square? Say this value is area is nothing but 200 centimeter, 10 power minus 2 whole square. How much is this? 10 power minus 4 divided by D. What is my D? 1 millimeter. 1 into 10 power minus 3. So what is the value? So guys, one thing I have to notify everyone. So guys, whenever you get such questions, no, observe this. So are you guys observing this? Why did they give exactly two zeros after them? All values, if you try to observe all the values, you could see that they have mentioned all the values with a dot and two zeros. So what do you mean by this? Is there any meaning in this? Is there any meaning in this? So these are nothing but, guys, yes. So these are nothing but significant digits, okay? So you might have studied significant digits in your 11th standard. So in some exams where you get easy questions, but you will have all the options correct. See, I hope most of you might have experienced this. In if you have given any mock exam by now, so you see all the options are correct. All the options are same numbers, same value, but their decimal point, yeah, their decimal point and number of zeros is different. So how many significant digits they have given here in the question in all three four yeah measurements which they have provided? What is the significant digits here, guys? See, the number of significant digits is here 1 2 3 1 2 3 1 2 3. So the number of significant digits is 3. So this means they are expecting the answer also in three significant digits. So you should provide answer also in three significant digits, okay? So this is what they mean. So ಕೆಲವೊಂದು ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ಈ ತರ ಕೊಡ್ತಾರೆ, ಮೂರು ಡಿಜಿಟ್ಸ್ ಕೊಟ್ಟು ಹಿಂಗೆ ಕೊಟ್ಟಾಗ ಎಲ್ಲ ಆಪ್ಷನ್ಸ್ ಸೇಮ್ ಇರುತ್ತೆ. ಬಟ್ ಆ ಆಪ್ಷನ್ಸ್ ಅಲ್ಲಿ ಯಾವ್ದು ನಿಮ್ದು ಕರೆಕ್ಟ್ ಆಪ್ಷನ್ ಅಂತ ನೀವು ಕನ್ಫ್ಯೂಸ್ ಆಗ್ಬೋದು ಅಥವಾ ಆಗದೇನೆ ಇರ್ಬೋದು. ಆ ಟೈಮಲ್ಲಿ ನೀವು ಯಾವ ಆಪ್ಷನ್ ಸೆಲೆಕ್ಟ್ ಮಾಡ್ಬೇಕಂದ್ರೆ ವಿಚ್ ಇಸ್ ಹ್ಯಾವಿಂಗ್ ಓನ್ಲಿ 3 ಸಿಗ್ನಿಫಿಕೆಂಟ್ ಡಿಜಿಟ್ಸ್, 3 ಸಿಗ್ನಿಫಿಕೆಂಟ್ ಡಿಜಿಟ್ ಇರುವಂತ ಆಪ್ಷನ್ ಮಾತ್ರ ಸೆಲೆಕ್ಟ್ ಮಾಡಬೇಕು. ಸೊ yes guys, so you have to select only 3 options which have 3 significant digits. Okay, so I have given the option with 3 significant digits here, 1 2 3. So that way this answer is very easy. Okay, so if you try to solve this, yeah, you'll get 8.854 into 2 is 17.708. So if I try to simplify with the powers, okay, 17.708 into 10 power minus 16 into 10 power plus 3. So you'll get somewhere around 17.708 into 10 power minus 13. So if you try to simplify that, okay, this is my capacitance value. Try to plug this value over here. Okay, substitute ಮಾಡ್ಕೊಳ್ಳಿ, solve ಮಾಡಿ. So 1 into 10 power minus 9 by 17.708 into 10 power minus 13. Okay, what is the answer, guys? How much would I get? 1 by 17.708. So they have mentioned something in your question also. Please, they take 1 by 1.77 as 0.565. They have mentioned this. Please use this data also. Okay. So 1 by 1.77 is 0.565 means somewhere. Yes, that is used somewhere, right? So they won't give you the direct answer, but they will give you some hints like this. Okay. So here, if I simplify 0.565, now I have to take care of only powers. Okay. So into 10 power minus 8. So 10 power, sorry, minus 9 by, so this is for 1.77, right? So I'll write 1.77 only. So if I shift this 17 as 1.77, illen barutte nange 10 power minus 14 barutte. So I'll get 10 power minus 14 in the denominator. So I'm taking 1.77 minus 14 or minus 12. Okay, minus 12, right? Yep. So 10 power minus 12 in denominator. Try to simplify this. You'll get the answer as 5.65. Okay. ಇಲ್ಲಪ್ಪ ಹಾಕಿದ್ದೀನಲ್ಲ. Tejas, I have added, right? Oh, here is it. Wait, I'll check. Let me check. Okay, I have missed this 200. Okay, guys, one more correction here. So this should be 10 power plus 5 plus 3 into 10 power 2. So have not taken, I had not considered this. So you'll get 10 power minus 11 here. So try to substitute all. You'll get 10 power 10 here. So you'll get 5.65. Okay, V will be equals to 5.65 volts. Okay, got this, guys? ಅರ್ಥ ಆಗಿದ್ಯಾ? Hope everyone have got this. Understood this? Yes, understood this. Please check with the powers always, guys. Thanks, Tejas, for that. Okay, next question for you guys. So the second part of the same question. So forget about the first part. So about the second part. Okay. Please try to solve the second part. So if the plate separation is now increased to 2 millimeters, what will be the new potential? What will be the new potential difference? Yes, correct, Tejas, correct, Prakash. So did I launch the poll? Okay, launch the poll for you guys. Nodi, try to answer the poll, guys. Yes, Hari Prasad, I hope you made necessary conditions, YouTuber. So please try to answer this question now. Prakash Gowda correct. Tejas correct. Okay. Rajwal correct. Ramakrishna Reddy correct. Bhargav correct. Yes, correct guys. Correct. Come on. So others, please try to answer. Others, please try to answer. Yes, correct, Lakshmi Nikita. That's correct. So yes, what's happening here? What is the thing they had given? So now for my capacitance, we know C is equals to epsilon naught A by D. So what they have done initially, I know it was 8.854 into 10 power minus 12 into A is 2 into 10 power minus 2 by suppression was 1 millimeter. Now it's 2 millimeters, 2 into 10 power minus 3. So what will be my net capacitance now? What will be my new capacitance? So if you want, you can solve from the beginning, or if you can try to skip, you can try to substitute, I mean, solve from the previous answer only. So you'd get C is nothing but 8.854 into 10 power minus 11. Guys, do you require steps? So you need to, so the steps goes like this, simple. So observe that. Say my 2 and 2 cancels. My 2 and 2 cancels. So 10 per minus 3 goes up. So I'll get 10 per plus 1. So I'll be getting 8.854 into 10 per minus 11 farads. So this is my capacitance. Now what I have to calculate? I have to calculate the potential. V is equals to Q by C. So 1 into 10 power minus 9 by 8.854 into 10 power minus 11. So if you try to solve, this is 1 divided by 8.854 is nothing but 11.29, or sorry, 0.1129 into 10 power minus 9 into 10 power plus 11. Okay guys, solve this. What will you get? 11.29 into 10. Okay, you'll get 11.29, right? So this is nothing but 11.3. Yes, correct, Prajwal. Option B by equations. Yes. So since we have three significant figures, we have rounded off to three significant figures. Okay. Okay, guys. So most of you had given me the right answer. That is option B. Hope we have you guys have understood this. Any doubts in this so far, guys? So in tomorrow's class, okay, now in next class we could start with, okay, I have to discuss one more thing, the parallel plate capacitor. So what is the practical application of a parallel plate capacitor? Okay, I'll try to finish this fast. Okay, can we construct a parallel plate capacitor, guys? Can we construct a parallel plate capacitor? Can we construct a parallel plate capacitor by ourselves? ನಾವೇ ಒಂದು parallel plate capacitor ಮಾಡಬಹುದಾ? Can we make our own parallel plate capacitor? Okay, so yes, we can. The answer is yes, we can. Say you can take some two thin aluminum sheets. Aluminum foil gotala. Hope everyone knows aluminum foil. So we'll take two strips of aluminum foil. Okay. On between these two strips, I'll keep one strip of plastic cover. So you see some plastic cover, right? So the yellow colored one is the plastic cover. So orange color one. So if I keep one plastic cover, and the other ends, in the other two ends, I'll keep some paper. I'll keep paper over here and paper over here. This is for insulation safe only. And if I try to sandwich all of them, so this is plastic, this is aluminum foil, and this is paper. This is also paper. Okay, if I try to keep everything together and if I try to roll, I'll get something like this. Okay, I'll get something like this. So this I can call it as a parallel plate capacitor. So this is the exact thing which is present inside our ceiling fan. Okay, I hope everyone have seen this. This is also called as a condenser. Have you guys seen this? Have you guys seen this? ನೋಡಿದಿರಾ ಇದು? Please reply, guys. Helodri, ಇದೀರಾ? ಏನಾಯ್ತು? Yes. So if we try to cut this, okay, now within, if we try to cut this, cut open this, it will look something like this. So if I try to cut open this parallel plate capacitor, it will be having something like this. So a thin plastic sheet and two aluminum sheets or copper sheets, thin layer of copper sheet and thin layer of plastic sheet and a thin layer of aluminum or copper. So these three sandwiched between each other and enclosed inside a hard casing. So this will make my capacitor, parallel plate capacitor. So Ivaga, I want you guys to calculate one thing, okay? Now help me calculate one thing. So this is my, yes. So this is my, yeah, we try to replace it, right, in fan and all. Yes, most of you might have seen. So the rated capacity of this parallel plate capacitor in your fan, if you get another chance to check, it will be somewhere about 2 point or 1.5 microfarad. So guys, yeah, we'll check that. Now, if my area of this capacitor, say on 25 meters length, say if I have a 25 meters length strip, if I have a strip of 25 meters length is 25 meters, and the distance is 5 centimeters. I mean, width is 5 centimeters. So it's not 25 centimeters. It should be okay. 25 meters. It should be 25 centimeters. But let me take 25 meters only. Okay, for simplification, quickly. And the separation between these two layers, this first layer and second layer, is 0.01 mm. So then, what would be that capacitance? Try to solve this. Try to solve this. But the rated capacitance is 2.25 microfarad. Okay. Here my rated capacitance is 2.25 microfarad. What will you get the capacitance as? This is homework for you guys. Okay. Guys, do this. No. We have. I'm showing you a cut open of a ceiling fan condenser. This is a ceiling fan condenser. Inside the ceiling fan condenser, that is the practical example, the perfect example of parallel plate capacitor. Okay. So how it would be? It will be having two thin plates of aluminum foil or copper foil separated by a thin sheet of dielectric material. Here dielectric material is plastic, a plastic sheet. So it's an insulator, right? Then for again in the edges, we'll be covering it with some paper for plastic insulation. Okay, these are the plastic insulation. So if we try to keep sandwich them and roll, we'll get a parallel plate capacitor. Then this is the same capacitor which is present in your ceiling fans. Okay. Now the rated capacity of this capacitor is 2.25 microfarad, and its dimensions are 25 centimeters into 5 centimeters, and distance between them is 0.01 millimeters. Okay, this is centimeters. Now calculate its capacitance. Compare it with the rated capacitance. It's mark ಮಾಡಿರೋ capacitance. It's the marked capacitance is 2.25. Now your homework is you have to calculate this and tell me why do you have that difference? Why do you have that difference? Okay. So you have, this is your homework for tomorrow, for next class. You guys have to tell me why there is a difference in capacitance, if there is any. If there is no difference, why there is not. Okay, guys. I hope you like the class. Please give me the feedback of how the class was. Okay. Cool, guys. So we'll meet again in tomorrow's, next class. For next class, guys, welcoming. Please come prepared with. Okay, this is the test which which this is the question which I was talking about the parallel plate capacitor. They will ask about the electric field. So yes, please come prepared to the class. Okay, next for next class, come prepared with energy stored in the capacitor. We'll discuss about energy stored in the parallel plate capacitor and also about energy density in the parallel plate capacitor. Okay, cool guys. Then we'll meet again in the next class. Please, everyone, please try to give the feedback and then you could leave. If you have any doubts, you could ask me. Okay, doubt is ಕೇಳಿ everyone. Question is Hari Prasad. I have this parallel plate capacitor, right? So this parallel plate capacitor, correct, Prajwal? Superb, awesome, Renewal. Prajwal already got the answer. Okay, so my question was Hari Prasad. Say I have given you the dimensions of this parallel plates of this capacitor. Now, can you find the capacitance? But the rated value of this capacitor is 2.25 microfarad. Is there any difference? Is there any difference in the calculated value? Have to let me know. Okay. So that's the homework for you guys. Okay. So we'll meet again on Monday's class, right? Next we have class on Monday. Okay, guys. Then we'll meet again on Monday. Till then, mast maja madi. Okay. See you guys. Bye bye. So thank you, bro. Vinay, I'm going to end the meet. Cool. Cool, guys. Thank you. Thanks for being here. So on Monday's class, I request you guys to come prepared and also please come on time. Okay. Okay, guys. Bye bye. Happy holidays. So guys, one more thing. You guys will be having test on electrostatics on Sunday, on day after tomorrow. Okay. Please prepare well. Please prepare well. You will be getting questions on all like all the concepts which we have covered. Okay. Please come prepared. All the best for your test. All the best for your test.